If you use git, you've almost certainly used the diff command. And it may seem like a pretty basic command, but there are several tricks that you can use to power up your diffing. So we're going to take a look at them in this video. We're going to start with the absolute basics. I'm here in a Git repository, and if I run diff, you can see we have made no changes. Well, let's go ahead and open the README file, and we'll throw a couple of simple lines of text in here. So to no one's surprise, if we run git-diff, we're going to see those changes we just made. But what exactly are the two things that we're diffing here? Remember, in Git, we have kind of three areas. We have a working directory, which is just any changes that we have on disk. We have a staging area, which is basically any changes that we are ready to commit and we have chosen to stage. And then we have committed code or committed content, stuff that is already existing in a commit. What we're seeing here is anything that is in our working directory, but not staged. Anything that has been changed, but has not yet been staged for commit. We could say git add, and we can add this file. And now if we do git diff, you'll see there are no changes to look at because all of the changes that we've made have been staged. And so there's no difference between the working directory and the staging area. If we pop this back open again, we add another line. Now, if we run git diff, we can see we only have this one new line, right? Because that's the only thing that is in our current working directory, but not in our staging area. But sometimes we want to look at the difference between what we are about to commit or what is in the staging area versus what is already committed, right? And so for that, we can use one of two flags. We can do git diff -- staged. That feels like the most natural name because we are talking about the staging area here, right? And in this case, you can see we have the three lines we initially added, but we don't have the one line that's currently in the working directory, but not staged. There's an alias for the staged flag, which is cached. I think cached is kind of the older version of this flag because I assume that just because that's the one I remember from when I initially learned this stuff, but I think staged maybe makes more sense as a name. So we have git diff and we have git diff -- cached. Now these are kind of your bread and butter. These are the commands you're going to be doing pretty much all the time. And so my recommendation would be alias these. And that's what I've done. If I run gd, that stands for, of course, git diff. And you can see we're seeing the difference between the staging area and the working directory. If I run gds, git diff staged, then you can see we see what is in our staging area and not yet committed. You can see if I just run which gd, these are alias to git diff staged. Notice that I have a -w flag in here. What does that do? Well, the -w flag essentially ignores white space changes in a diff. It will not show you changes that are just white space changes. Let's see this in action. If we open our README again, let's indent our second line here. If we run git diff, we can see a change to that line. And then we also see, of course, the new line we've added. If we run git diff -w, we only see this new line that we've added. We don't see the new indentation. Now we do kind of see it, of course, in the output here because anytime we have a changed line, we get some context around it, but it's not shown as something that is actually different here. And so this can be kind of weird, right? Because if I pop open the README file again, let's delete this line. So the only change that we have now is white space. If I run my alias gd, I don't see any changes. And you might think that's not a great idea. Here's the way I think about it. Most of the projects that I work in these days have linting and formatting tools built in, run in the editor or on save, those types of things. And so I want to never think about white space. If I see a white space change here, it's not really something I probably did intentionally. Maybe I did a -- no verify earlier, and that's why I committed something with poor white space. Now it's being corrected. That's fine. What I really care about is actual content changes, not white space changes. Now, if you're in a language like, I guess, Python or another language where white space changes do matter and kind of change the behavior of your code, you probably don't want to use that flag. But in JavaScript or TypeScript land, where I'm mainly living, this works just fine. And of course, I can always do git diff instead of gd if I do want to see the white space changes. So that is kind of the core behavior of git diff. Now, of course, we can also use diff to diff between two existing commits. So if I just run my git log here, and I'm going to grab this commit and this commit, what we can do is if I run git diff and I paste one of those commits, and then I paste the other one, we can kind of get a diff of what are the changes between these two commits, right? That can be pretty handy. We can also, if I just grab something from a couple weeks ago, if we run git diff with just one commit, well, then we're diffing it against head. Now, sometimes you want to diff one file against another file and not two versions of the same file. The way we can do that is by doing git-diff -- no index. And now we can pass two different file names. These files have nothing in similarity, but just for fun, let's do readme and package.json. And what you can see here is we get the git-diff output, but it's between two different files and not two versions of the file, right? And if you didn't know about this, you might think you just had to do the built-in diff command that most machines have, which, to be honest, I don't like this output as well. I appreciate the color and some of the better formatting that we get in a git diff, and so that can be pretty useful. In fact, this is such a useful thing because you can use it on files that are not inside a Git repo. If I move up a directory here to my code directory, which is not a Git repo, as you can see, typically we would have to do diff A and B to diff this file, but we can do git diff A and B. And notice I didn't use no index here. That's because one or both of these files, in this case, is not in a Git repository. And so Git says, that's fine. I know how to diff two files. I'll go ahead and do that for you. Let's move back into our repository here and let's pop open this README again. So we have these files currently staged, and let's say I want to remove the word small here. If I run git diff, we can see that an entire line has changed, of course, and git diffs usually work on a line by line basis like this, right? And so we can see we've removed this line, replaced it with this line. And in this kind of simple example, it's fairly easy to just scan it and see where the actual change is. But if you have a larger diff, obviously this is usually going to be code you're looking at. There are lines that have changed. It can be tricky sometimes to see exactly what the diff is. And so this is why one of my favorite flags for diff is word diff. What this will do is, instead of diffing line by line, it kind of diffs by word or intraline, if you will. And so what we can see now, if we look at this diff, is it shows us exactly what was removed right here. We can see that we removed the word small before the word library. If we open README again and maybe say we replace this with awesome, and we do another word diff, we can see what this looks like. We've removed small and we've added awesome. And so this gives us kind of a more high resolution, you could say, view of what has changed. Instead of showing me just this line was replaced with this other line, we can actually see inside that line, what are those changes? And this can be really handy if there are changes that you want to review more thoroughly with kind of a fine-tooth comb before you actually commit them. There are literally hundreds of combinations of flags that you can use with git diff. We're going to look at one more, which I think can be useful here, and that is git diff -- stat. This is essentially a summary of what the changes are. And of course, because we're just doing git diff and not -- staged, this is between the working directory and the staging directory. So we can see that our README has two changes. We have one insertion and one deletion, and that is what that change is. You know, we can see that we also do have some things committed. So if we do -- staged here, we can see differently. We have 3 insertions like that. If we do a git add and we do that one more time, well, I guess because that last change was intraline, it still looks like 3 insertions for the full lines. But this is a nice little command if you want to just get a quick summary of some of the stuff that's changed. There are a few other versions of stat. There's like, I think numstat, which just gives us columns. This one is a little more useful if you want to be passing this output to some script, right? The stat output here is nice for me to read here on the command line, but numstat tells me I have a column here for insertions, a column for deletions, and then the file name. And so that can be kind of handy if you want to maybe do some kind of processing or scripting off the back of that command. Now, if you head over here to the Git website, you can see a list of just all the possible flags that you can use with git diff. A lot of these different flags have to do with doing specific diffing when it comes to how you merge various branches or commits. There's a lot of stuff to do with controlling the output in various ways to make it better for perhaps other tools to consume, maybe different diffing algorithms. You can also choose maybe different parts of your repository that you're going to diff, like ignoring or including submodules. There's all kinds of stuff that you can look at here. And to be honest, a lot of this not super useful in your day-to-day. Good to know it's here and you can come check it out when you need it. But I think what I've showed you here today is the stuff that I'm using 99, basically 100% of the time. And even just the basic git diff staged, I'm using that probably dozens of times a day. So this was just a quick little tip I wanted to share with you guys, some of the fun ways you can use git diff. If you have other git diff tips that you want to share in the comments below, please do. Thank you guys so much for watching, and I will see you in the next one.